So the goal of the brightness sanity check is simple. It's to prevent unnecessary stress without sacrificing the lighting outcome. You don't need calculations or software to do this. You just need to challenge assumptions before they become permanent. Bigger course that we do, we show about all the calculations about brightness and using a lighting calculator and understanding some lighting standards like the required lux level. But this is to help you think, that build that ABCDE process, which has brought tremendous success to our business. So this check helps you separate required brightness from assumed brightness, which is where most of the overspec problems begin. So the questions you want to ask is, what visual task is this lighting actually supporting? Navigation through a corridor, accent lighting, task, or feature. Then what's driving the brightness decision? Is it function? Is it aesthetic expectation? Is it fear of complaints? I'll give you a most common application mistake. Somebody wants bright lights for an Instagrammable area in their business. So they use a lot of bright LED lights, and the lights actually become very glary to the customer, where the customer can't even enjoy it. When they take pictures, there's glare showing up and it looks overlit. Then they don't put aluminum or any sort of thermal management system into it, and the LEDs start to lose segments because they're running as a commercial space, was running 24 hours or what have you. So those are some of the things you could look at. 3, could the same effect be achieved with less output? More uniform distribution, better placement, layered lighting, not just depending on that one light source. Now the 4th one is, if this ran at full output for long periods, would that be acceptable? Thermally, visually, long term. If the answer to number 4 is no, then the brightness decision deserves an adjustment because we're going for longevity. If you wouldn't be comfortable running it at full output long term, you've probably specified too much brightness, or in some cases, too little brightness. So now just take one current or upcoming job and answer the questions for the brightness sanity check, and think of any answers that resonated with you where brightness was an issue on a past job. So a safe decision rule could be starting with the lowest brightness that achieves the visual goal and not the highest brightness that the product allows. Let's say LED strips. One LED strip has, at one point, our LED strips had 4 ounces of copper on the circuit board per meter. A lot of them now are advertising 2. But that same 2 ounces is being used on an LED being driven at 2.5 watts per foot, 4.5 watts per foot, and 6.5 watts per foot. So how could that be that 2 ounces is sufficient for 2.5 watts all the way to 6.5 watts? There's going to be some operational conflict down the line, and the one at 6.5 watts per foot on the same amount of copper is going to get strained. So you just don't want to go with, okay, brightness is the best, unless you're prepared to dim it to an acceptable level. But then dimming becomes a whole other issue on the circuitry and the control planning aspect, which we'll talk about later. So we've seen installs reduced output slightly and improve the uniformity and ended up looking with a better looking space. I'll probably send you a picture here of a building that I've seen going up, and they've used no lighting technique. They just put on highlighting LED. It's overly bright, where it has become absolutely glary to look at the building. You can't even enjoy the building because the light is overpowering the building. So the beautiful architecture of the building is absolutely hidden, and they're using an LED that's out there. It's going to be driven to a high brightness and most likely fail in a short time. So that's it for brightness. Next, we'll take a look at control and circuitry and design red flags. These are the areas where small decisions quietly create big long-term problems. And again, I'm going to cover this deeply in our full course.